Hi, I'm Mr. Herzon, and I teach honors biology at Thomas Wooten High School. And welcome to my Chromebook studio. I'm here today to help show you how you can use molecular models in this biochemistry unit to learn about the four organic compounds: carbohydrates, lipids, proteins, and nucleic acids. There are two very, very important chemical reactions that you do need to know in this module, and that is dehydration synthesis and hydrolysis. Um, since this is the week of carbohydrates, um, it's really pertinent to get you started on your molecular models. And there are only three things that you need. First, a good source of cardboard, like this cardboard box. All right. A permanent marker. And you know what? If you don't have a permanent marker, an ink pen will do just fine. And a pair of scissors. Okay. So, we're off. Okay. Let me move my camera over to my studio that I have set up here. Okay, I think you can see that all right. So I've already trimmed uh, some of the cardboard into shapes. All right, and you can see that this is about the length of one of my fingers. All right, and as wide as up to um, the second knuckle right up here. All right. And what I'm going to write on this one is the word monomer. This is an important term for you to know. And I'm going to write it on both sides. Okay. And now with your scissors, cut along the side, maybe up to the first letter on both sides. Okay. And you can see I have these other cutouts. All right. I have an OH for a hydroxide group. I'm going to attach it to my monomer. And since uh, this unit, we're learning about carbohydrates, the monomer for carbohydrates is one of three organic molecules. Okay. And I got them written down here. Let you see that. There is glucose, fructose, and galactose. All three of these have the same molecular formula. What's different about them is uh, the structure of the molecule. Um, Molecules that have the same chemical formula but different structure are called isomers. And so this monomer that I constructed could stand for either one of these three. Okay, so let me go ahead and build a couple other monomers, and we can pretend that these are representing the glucose molecule. And I'm doing this in any order. It really doesn't matter. But I got to make sure, what you have to make sure is that you have a hydrogen on one end and a hydroxide group on the other end. Okay? So the first class of carbohydrates are called monosaccharides. Okay? Monosaccharides are the building block for more um, for macromolecules or macrocarbohydrates. All right. If we want the second class is called a disaccharide. For example, like the molecule of sucrose, which is a glucose molecule and a fructose molecule bonded together. Okay. Another one is galactose. I'm sorry, is maltose. Okay. So if you combine two glucose molecules, that is what you need in order to make maltose. Okay. All right. So I have two monomers, and these could be two glucose molecules. How we put them together is by a technique, a chemical reaction known as dehydration synthesis, where the D stands for taking away. Okay. Or, and what we're taking away, hydration, is we're taking water away. So, one thing that's not here is a special type of organic compound called an enzyme. An enzyme is a type of protein that actually helps catalyze or speed up the chemical reaction. So, an enzyme called dehydrogenase works by removing an OH on one monomer and a hydrogen on the other and forming a molecule of water. Okay, an OH that you can see here. All right. And now we can bind these two glucose or these two monomers together. And now we have our disaccharide, which if these were two glucose molecules, this would be maltose. Okay. If I'm making the third class of carbohydrates is a polysaccharide. We would need a third monomer and more of the enzyme dehydrogenase. And what that will do is we'll remove our hydroxide from one and the hydrogen off of this one. And now we'll have our second molecule of water. And now we have our polysaccharide. Okay. So, um, this is an easy way for you to have an activity in which you can make organic molecules by using these cardboard cutouts and model the process of dehydration synthesis. Now, the opposite of how we can break down these polysaccharides, like in some of the foods that we eat, like lettuce, they're filled with carbohydrates. But our bodies can't utilize those types of carbohydrates. I mean, we don't have leafy ears, okay? So what our body does, it digests those carbohydrates and gets them down to building blocks or monomers. So we can construct, um, say, like connective tissue, um, which is layers of of macromolecules, organic molecules. I meant to say. So the process is known as hydrolysis, where another type of an enzyme is used, and it will break apart the two monomers and add the correct hydrogen to one end and a hydroxide to the other end. Okay, and then break apart these two. We have to release our water molecule for the OH, and then the hydrogen. And now we're back to having these three monosaccharides. Okay, so this is modeling the chemical process known as hydrolysis. So there you have a little tutorial on how to make your molecular models out of cardboard to simulate dehydration synthesis and hydrolysis of carbohydrates. Our next video will look at dehydration synthesis and hydrolysis of lipids. So stay tuned, and thanks for stopping by.